Hello everyone, myself Anshika and we are going to discuss chemistry part test 18. So question number 51 is we have to discuss acidic strength of the oxides. So as we know, acidic strength along the period increases and down the group decreases. Metals form basic oxide. So CaO and CuO will form basic oxide. H2O is amphoteric oxide. CO2, it is formed by non-metals, so this will be acidic oxide. So the overall order will be Ca will be least acidic, then Cu, this is on the basis of along the period. H2O is amphoteric, then CO2 formed by non-metals, so acidic oxide. Question number 52 is on the silicates. If we will see, we have to find the incorrect statement. Statement number 1 is pyrosilicate. This is, if we are going to draw the structure of pyrosilicate, it will be Si, O minus, O minus, O minus, O, O, Si, O minus, O minus, 1, O minus. So we can see one oxygen is shared between two silicon Si. So one oxygen is shared. Now here we will see the second case. So before discussing the second option, I will tell you the general formula of cyclic silicate, that is SiO3N2N minus. If we will see this case is also the case of cyclic silicate. In this cyclic silicate, Z is what? Number of shared oxygen equals to 2. So this is also correct, 2 shared oxygen. Now about third one, this is pyroxene. So single chain silicate or linear silicate, linear or single chain. Chain silicate are known as pyroxene. What is the general formula of linear chain silicate or single chain silicate is SiO3 2 minus whole n. If we are going to draw the structure of single chain silicate, it will look like this, in which in the middle there will be silicon and in the outer side it will have oxygen, 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 oxygen. This oxygen 1 by 2 shared, this oxygen 1 by 2 shared, this one is 1. So overall Z is equals to 2. So 2 oxygen will be shared. Now in the, so this case is also, this statement is also true. Now for the fourth statement, if you will go for the fourth statement, it says 3-dimensional network silicate. So if you will see the rough structure of 3-dimensional network silicate, it is Si, O minus, O minus, O minus. So Z is equals to 4, that is number of oxygen shared in this case is 4, but here it is written 3, so this is incorrect statement. General formula of 3D silicate is SiO2. Okay, so keep in mind this thing. Question number 53, you have to tell about the bond angle. To compare bond angle, we have to follow one sequence, that is first we have to find the steric number, then we will go to hybridization, then percentage S character. Then after percentage S character, we will see the number of lone pair. Steric number 4, 4, 4, 4. Bond pair is 3, lone pair 1. Steric number hybridization will be sp3, 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 sp3. Now percentage S character 25, 25, 25 and 25. Number of LP 1, 1, 1, 1. Now central atom phosphorus, 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 phosphorus. Now you will go to side. So this is the sequence you have to follow while comparing the bond angle. So for the side atom, bond angle is directly proportional to size of side atom and inversely proportional to electronegativity of side atom. So you can write from here that side atom in the first case is fluorine, second case chlorine, bromine and iodine. Iodine is having maximum size, so it is directly proportional to bond angle. So Pi3 will have highest bond angle. Question number 54 is solid state PCl3. We have to discuss about X minus and Y plus. So PCl5 in the gaseous state having hybridization sp3d, and what is its electronic geometry structure? Trigonal bipyramidal. In the solid state, PCl5 exists in the form of ions, that is ionic solid, cation and anion. PCl4 plus is the cation and PCl6 minus is the anion. The steric number of PCl4 is 4. Steric number of PCl6 is 6. Steric number 4 hybridization will be sp3. Steric number 6 hybridization will be sp3t2. So hybridization sp3, it means tetrahedral. Hybridization sp3d2 octahedral. Answer B will be your correct answer. Now we will move to the question number 55, which is asking for the number of unpaired electron in gaseous species Mn2 plus, Cr3 plus, vanadium 3 plus respectively, and also we have to tell the most stable species. So first we will write the general electronic configuration of Mn, Cr and vanadium. So what is the general electronic configuration of manganese? It is 25, so it will be argon 18 and 3s, 4s2, 3d5. For the chromium is 24, so argon 18, 3s1, 4d5. Now in the case of 4s1 and 3d5. In the case of vanadium, it is 23. So argon 4s2, 3d3. Now we will write in the form of ions. Mn2 plus will have Ar18, 3d5. Chromium will have how much? Chromium 3 plus will have Ar18 and 3d3. Vanadium 23, vanadium 3 plus will have Ar18, 3d2. Now d orbitals right now are in the degenerated form. What does the word degenerated means? That all the 5 orbitals are having similar energy, same energy, whereas this d orbital is split into 2 parts, T2g and Eg. T2g 3 orbital will have same energy, so 3 orbitals are degenerated and 2 orbital will have same energy, so these 2 are degenerated. Now we will do filling of electron to know the unpaired electron. In the first case, if you will go and you have to fill 5 electron, okay. In the case of manganese, 1 2 3 4 5. So number of unpaired electron 5. Now in the case of chromium, again you have to find, so this we will see in this only. Chromium is 1, 2, 3. In the case of vanadium, if we will go, then you have to fill how many electron? 1, 2. So if you will see, T2G is fully filled, okay, half filled T2G orbital, which is more stable as compared to the other two cases. So in this case, the answer will be your C answer, okay, that manganese is having 5 unpaired electron, chromium is having 2 unpaired electron and 3 unpaired electron, and vanadium is having 2 unpaired electron, and the most stable species is chromium. I hope this question is clear to you all. Okay, now we will move to the next question. This splitting is according to crystal field splitting theory. Okay, now we will move to the next question, that is question number 56, the relation between X and Y. First of all, what is X and Y? X is axial bond and Y is equatorial bond. So axial bond, in general, axial bond is greater than equatorial bond. In the case of PCl5, there are two type of bond length. Whereas in the case of PF5, there is only one type of bond. Due to flexionality, or you can say Bery-Pseudo rotation. Okay, in the PF5, Bery-Pseudo rotation is present or not, you will check. Okay, and now we will see that there are three type of bond angle. One is between equatorial and the bond angle is 120 degree, and one is between axial equatorial, the bond angle is 90 degree. One angle is between axial and the bond angle is 180 degree. So as the bond angle is inversely proportional to bond length, if you will see, in the case of axial and equatorial, the bond angle is 90 degree. Bond angle is 90 degree. Bond angle less, repulsion more, bond length more. So answer will be, so according to this, answer will be X will have more bond length as compared to Y. So answer will be your A. Question number 57, the compound we have to, this is our first compound, SiH3, SiS3 and SiS3. We have to tell about the electronic symmetry structure or the molecular structure of this compound, and we have to compare its basicity with CH3 whole thrice n. Okay, so we will compare one by one and we will see. Your silicon is having vacant d orbital. In this vacant orbital, this lone pair will go. This is due to back bonding. Okay, so due to back bonding, here pi bond formation will take place. Okay, if you are going to tell about the hybridization, so for nitrogen the hybridization will be sp2, because hybridization is what? Sum of the sigma bond and lone pair. So this lone pair is involved in the bond formation, and the pi bond is not counted as a hybridization. So how many sigma bond? 3 sigma bonds, so sp2. Structure will be planar. Now this lone pair is forming involved in the bond formation, so it is not available to show the basic nature, whereas this lone pair, as the carbon do not have any vacant d orbital, so this lone pair will not involve in the back bonding, so this will act as a basic lone pair, this will act as a base, so obviously this will have more basic nature. So option B will be your correct answer, that SiH3 whole thrice n is planar and it is less basic than CH3 whole thrice n. Now we will do question number 58. In the question number 58, it is the F block element. For the F block element, keep in mind for GD and EU, these are the two important elements you have to keep in mind. Okay, the electronic configuration. For the GD, the general electronic configuration is 4F7, 5D1 and 6S2. So ZD 3 plus is 4F7. It is asking about the half filled 4F subshells. 4F subshell contain how many orbitals? 7 orbitals. Okay, and it is having 7 electrons, so each electron will have 1 each orbital will have 1 electron. So this is your half filled 4F subshell. Answer will be your C. Now question number 59, it is asking about how many EDTA molecule are required to make an octahedral complex with a calcium ion. So for the calcium ion, and it is octahedral, so obviously the coordination number will be 6. It means we need 6 ligand. Okay, it means we have to form 6 bond, not 6 ligand. So if you will see the EDTA, it is ethylene diamine tetraacetic acid. So first this is your ethylene. Okay, now diamine is nitrogen and tetraacetate. Tetraacetate was CH2 C double bond O minus. Similarly, CH2 C double bond O minus. CH2 C double bond O minus. CH2 C double bond O minus. If you can see that there are how many donor atom? 2 nitrogen will act as a donor atom and 4 oxygen will act as a donor atom. So EDTA, 1 minute. EDTA is hexadentate ligand. So if it is hexadentate ligand, so it can form 6 bond with 6 distinct position. It can form 6 bond with 6 distinct position. So obviously Ca has to form, it is octahedral complex, it has to form 6 bond, and one EDTA alone can form 6 bond. So how many molecules is required? Only 1 molecule is required. Option D will be your correct answer. Now in the detection of CO2, lime water turn milky due to the formation of. So first you should know what is lime water. CaOH is your OH whole twice is your lime water. Okay. When you will pass with the CaOH whole twice, if you are going to pass CO2 excess lime water, this is lime water, it will turn into milky. Why milky? Because of the carbonate which is having white PPT. Plus H2O. Okay. So answer will be C. Question number 61 is about Lysine test. First thing, why we perform Lysine test. Lysine test is performed for the detection of nitrogen, halogen, sulfur and phosphorus. To perform Lysine test, we perform in the organic compound for the detection of nitrogen, halogen, sulfur and phosphorus. First we do its fusion with sodium. Okay, so if your organic compound is containing nitrogen, so once you are doing fusion with the sodium, it will convert into NaCN, why we are doing fusion of Na? To convert covalent compound, as the organic compound are covalent, into ionic compound. So further we will do other tests with this organic compound. So you can see that it is, if your organic compound will contain nitrogen as well as carbon, then only it will convert into NaCN. But here so that we have to see. In the first case, NH2CO NH2, this is what? Ammonia. Ammonia is containing carbon, so it can convert into ionic compound NaCN. Whereas in this case, this is your hydrazine, NH2 dot 2HCl. In this you cannot detect nitrogen because it is not containing carbon. So obviously it is not going to convert into NaCN. Then that is the organic compound, that is covalent compound, is not going to convert into ionic compound. So you cannot perform Lysine test. So answer will be your B. C is also containing carbon, D is also containing carbon as well as nitrogen. So after fusion with sodium they will form NaCN, and you can perform further test. In Lessine test, question number 62, in Lessine test for nitrogen, the blue color is due to the formation of. Now in the Lessine test, you have to tell that the blue color is due to the formation of what? So this is ferric ferrocyanide. We will discuss how it is ferric ferrocyanide by what are the reaction involved in this. So first, what is there? NaCN. Nitrogen test, as I told you in the above question only, that first we will do, if our organic compound is containing nitrogen, carbon and nitrogen, first we will do sodium fusion and it will form sodium. We will fuse with sodium and it will form NaCN. Now we will do further reaction with NaCN. NaCN will react with FeSO4, ferrous sulfate, and it will form FeCN whole twice Na2SO4. Now FeCN whole twice plus 4 NaCN will convert into Na4 FeCN6, that is sodium ferrocyanide. Okay, once it is converted into sodium ferrocyanide, Na4 FeCN6 plus 4 Fe3 plus, that is it will do reaction with ferric chloride, and then it will form Fe4 FeCN6 whole thrice plus 12 Na plus. This will contain Persian blue color. What is its name? Ferric ferrocyanide. So what will be your answer? Ferric ferrocyanide. Now paper chromatography you have to tell. So first I will tell you something about paper chromatography quickly. PCR 1. Paper chromatography. Used to separate, identify and purify component of mixture. In paper chromatography, both moving and stationary phase phases are liquid. Okay, so here it is asking about the moving phase is liquid as well as the stationary phase is also liquid. So you have to keep in mind that in the paper chromatography, liquid as well as moving phase are in liquid. Moving and stationary phase are in liquid. Okay, so further I will tell you about stationary phase and moving phase. Okay, so stationary phase, very uniform absorbent paper. Okay, and moving phases, liquid solvent. Okay, or mixture of solvent. I hope this is clear. Now we will move to the question number 64. An organic compound containing carbon, hydrogen, nitrogen gave following analysis: carbon 40%, hydrogen 13.33%, nitrogen 46.67%. Its empirical formula would be. Okay, so for empirical formula, first we will calculate number of moles in each case and then simplest ratio. carbon 40 divided by 12, so number of moles will be 33. Hydrogen 13.33 divided by 1, so it is 13.33. And nitrogen, it is how much? 46.67 divided by 14, so it will be 3.33. So you can see that hydrogen is 3 times of carbon, and hydrogen is 4 times. Hydrogen is 4 times of carbon. Okay, and it is also 4 times of nitrogen. So in the simplest ratio you can write 1 4 1. So from here you can write the empirical formula, that is carbon, hydrogen, 4 and nitrogen. So I think answer C will be your correct answer. Now in this question number 65, what you have to tell, which of the following statement is true regarding the above conversation. The magnetic moment of certain complex of CO was found to be itna. What is magnetic moment? Mu is equals to under root n plus 2. So in the first case it is given that the magnetic moment mu is 4.89 Vm. So 4.89 is equals to under root n plus 2. So if you will solve, n is equals to 4 you will get. Okay, by random number you can put also, you can guess, like here n is equals to, if you will put 4 into 6 under root 6 4s are 24. 24 square root you can nearby 4 4s are 16, 5 5s are 25. So it will lie in between them only. So from like this you can do these type of calculations. Okay, then EAN. What is EAN? EAN is effective atomic number. How you will find atomic number? Minus x. X is what? Minus oxidation state. Okay, OS is your oxidation state, and then once you have done this, that is atomic number minus oxidation state plus 2 into number of electron donated by ligand. Okay, so in this case ligand is not given, so we will assume that it is forming octahedral compound. How it is forming? Let's assume forming octahedral complex with ligand, with monodentate ligand. Okay, ligand. For each case we are assuming that cyanide is our ligand, so it is monodentate, it will give you 1 electron. So in the first case EAN is given how much? 36. 36 minus atomic number. What is the atomic number of cobalt? It is 27 minus x. X is oxidation number. Okay, oxidation state that you don't know, plus 2 into that cyanide will give you 1 electron. So 6 cyanide will give you 6 to 1 electron each cyanide. So it will be 26 minus x plus 12. So x will be plus 3. This is your first case. Now we will see for the second case. Second case mu is given how much? It is given 3.87. So 3.87 is equals to under root n plus 2. So from here if you are going to solve, then n will be how much? You will get, if you will solve, n will be 3. Okay, once you have solved the n, then you will solve the for the effective atomic number. How much effective atomic number is given? That is 37, and 37 is equals to 27 minus x plus 12. So this you will get how much? Plus 3. In the third case it is given that it is diamagnetic. If diamagnetic, then n will be 0. The number of unpaired electron will be 0. So mu will be 0. And about EAN, EN is given 37. So if it is given 37, 37 equals to 27 minus x plus 12. So how much you will get from here? X will be your plus 3. Sorry. in the second case you will get plus 2. Okay, sorry. Then this is clear. So according to this, you are having plus 3 oxidation state, plus 2 oxidation state, and plus 3. So option A will be your correct answer. What about option B? Option B is given that A and B is having hybridization sp3d2 while C is dsp3. So we cannot comment anything about hybridization until and unless ligand is not mentioned, because ligand decide that the hybridization will be what according to strong field and weak field ligand. So we cannot comment anything on the hybridization. What about option number 3? Option number 3, C is asking for the spin multiplicity. What is spin multiplicity formula? Okay, I will write in the short form, that is SM. Spin multiplicity is small m, S is equals to 2s plus 1, where this S is n by 2. N is what? Number of unpaired electron. Unpaired electron. So number of unpaired electron in each case we have already calculated. So in the first case n is equals to 4. So S will be how much? 2 into 4 by 2 plus 1, 2 2 is 4. So it will be 5. In the second case, what will be your spin multiplicity? 4. In the third case, it will be 1. So it should be 5 4 1, but it is here 4 3 1. So C is also incorrect. What about D? D, it is given oxidation state plus 8 plus 6 and plus 1. Oxidation state cannot be plus 6 plus 8 and plus 6 and plus 8. It can be plus 1 plus 2 and plus 3. Okay, I hope this is clear. Question number 68, it is asking about more stability. Okay, so if you will see this one, Fe, this is which ligand? Oxalate. C double bond O, O minus, C double bond O, O minus. Okay, so this is bidentate ligand. It will form 3 5 member ring. So if this is chelating ligand, what is chelating ligand? The one which is forming ring. Okay, so the complex, those complex which are forming ring, 5 member or 6 member ring, are more stable than those complex which are not forming ring. Okay, what is the hybridization state? What is the oxidation state of iron in this? So this you are having in one oxalate, you are having -2 charge. For one oxalate, you are having -2 charge. So you can calculate the oxidation state. X plus -2 into 3 is equals to -3. So X will be plus 3. Iron is in plus 3 oxidation state with 3 5 member ring. So obviously it will be more stable. Now question number 67, it is saying mixture of X 0.02 moles of first complex, okay, and 0.02 mole of second complex was prepared in 2 liter solution. So 0.01 mole of first complex and 0.01 mole of second complex was prepared in 2 liter of solution. 1 liter of mixture. Okay, then they divided this. Once they have added, then they divided this in 1 liter, 1 liter. So whatever will be the molarity previously, it will after separation, after dividing this into 1 liter, molarity will remain same. Molarity before separation and after separation, molarity of the solution will remain same. So molarity is what? M is equals to N by V. So as the V is reduced, okay, volume is reduced, so number of moles is 0.2 mole, 2 moles. So number of moles will also be reduced. So here 0.1 mole of first complex plus 0.1 mole of second complex. Previously in 2 liter it was 0.22 mole of first and second complex, but now in 1 liter 0.1 mole of first complex and 0.1 mole of second complex. Similarly, In the second solution, it is 0.1 mole of first complex and 0.1 mole of second complex. So molarity will remain same. Now what it has to do, 1 liter of mixture will do reaction with excess of AgNO3. So out of complex number 1 and 2, which one will do reaction with complex number 1? AgNO3. Complex number 1 will do reaction with AgNO3 and it will form AgBrPPT. So now we will see the reaction. Reaction is what? CONH3 SO4Br plus AgNO3. What it will form after reaction? After reaction it will form CONH3. Okay, there is one correction. It should be CA. Okay, SO3 whole NH3 whole 5, NH3 whole 5, SO4 and NO3. Okay, and plus AgBr. And in the second case, SO. So if you will see the stoichiometric coefficient, it is 1, 1, 1, 1. So the product form is 1 mole. So 1, 1. So if it is 0.01 mole, so product will also form 0.01 mole. So X, this will be your X will be how much? Y will be your 0.01 mole. Now we will see about Z. So in the case of Z, NH3 whole 5 Br and SO4 plus BaCl2. It will form CONH3 whole 5 and Br Cl2 plus BaSO4 की कौन से कलर की BaSO4 will form what color PPT? White color PPT. So if you will see stoichiometric coefficient, it is again 1, 1, 1, 1. So if you are taking 0.01 mole of this, it will form 0.01 mole of the product also. So your Z will also be 0.01 mole. So your answer will be 1. Now for this question, if you will see what you have to find, the correct match below the complex and their lambda max. Okay. So first you will see 1, 2 and 3 option. It is given. You have to see the ligand. What is the ligand given in the first case? According to spectrochemical series, NH3 will be among this all. NH3 will be strongest ligand. Then NCS, this is thiocyanate. Then F minus. And strong field ligand will give you maximum splitting. Okay, so if maximum splitting will be there, then splitting energy, this is your splitting energy. Splitting energy. For this strong field ligand, splitting energy will be maximum, and splitting energy is directly proportional to mu and directly proportional to and inversely proportional to 1 by lambda. So the one which is having strong field ligand will have maximum splitting energy, so it will have minimum lambda max. Okay, so for this the order of lambda max will be NH3, then NCSF and F minus, inverse of this. So according to this, the option D will be your correct answer. You can see that lambda max you can see from here. C is the maximum lambda max, and maximum lambda max will be for C is maximum lambda max, and it is for the second one. So second one, C will be second one. Then after that NCS, A should be for NCS. NCS is first one. A. Okay, this is your minimum. Minimum will be B. B will be your. Okay, in this case, you will see your answer number D is your correct answer. C will be your second one. Then out of A and B, A, the one which is having minimum will be this one, B. B should be your first one. Okay, B is your first one and then A is third one. I hope this is clear to you. And then in this question you have to tell about the IUPAC name of this S2PtCl6. So in this case you are having 2H plus and PtCl6 minus. This is your acidic complex. This is your so in acidic complex you have to keep in your mind that name should end with ic acid. Okay, instead of ate suffix for an ion. Okay, first you will find the oxidation state of this. So oxidation state will be how much? X plus minus 1 into 6 is equals to minus 2. So X will be how much? 4 plus 4. So Pt is in plus 4 oxidation state. So what will be its IUPAC name? Hexachloroplatinate acid. Okay. Chloro, in the place of chloro you can use chlorido also. Option number D will be your answer. Okay, here 4 platinic 4 acid. Okay, then for the question number 70 you should keep in mind the colors. You have to keep in mind these colors. For this we have discussed previously in this slide only that this is Persian blue color. This is what? Ferrocyanide. What is this? Ferrocyanide. Okay, so ferrocyanide is what color? Blue color. Then from the option elimination only you can do that. For D it should be 4. For the D 4 is given only in the B, whereas in the rest of it is not given. But we will discuss this color also. For the A it will have white color. Okay, and in the if you are having NO2, so for the trick you can keep that if you are having NO2 it will have brown color. Okay, brown color fume, brown color. For the NO2 you can keep this in mind. So B will be, oh wait, D is your 4 and B should be your 1. It should be for the A it should be 2. No, wait for 1 minute. If you are having D will be your for the D you are having 4th one, and then for the C it is 1st one. Okay, sorry, it's my mistake. Okay, for the A you have to keep these colors, you have to keep in mind. For the D you are having only in the last case you are having 4, so B will be your answer. For the other rest of the cases you have to keep in mind that for the A it should have white color. Okay, then for the B will have yellow color, and for the C you will have brown color. Okay, so this you have to keep in mind. These colors you have to revise in the salt analysis, then only you have to keep in mind these colors. And but for this we have already discussed that this is Persian blue color. Okay, ferrocyanide. I hope this answer is clear to you. Now we will do numerical answer type question. Now question number 71. For the 71, Fe is in +3 oxidation state. So first we will write the general electronic configuration of Fe. Then we will write for the Fe3+. So what is the general electronic configuration for Fe? It is argon, that is 18, 4s2 and 3d6, that is 26. Okay, and then you are having cobalt, that is 27. So for this it is Ar 18, 4s2, 3d7. Okay, so Fe 3 will be how much? Fe3 will be Ar 3d5. Okay, and cobalt 2 plus will be how much? It is Ar 3d7. So for the 3d7, if we will see how many unpaired, 1 2 3 4 5 6 1 7. So here n is 3 number of unpaired electron. In this case, if you will see 1 2 3 4 5, n is 5. Now mu is magnetic moment, which is under root n plus 2. So in the mu 1 for the Fe will be under root 5 into 7. Mu 2 will be under root 3 into 5. So mu 1 upon mu 2 will be under root 5 into under root 7 and under root 5 into under root 3. So root 5 will cancel and it is equals to under root A upon under root B. So A is equals to 7 and B is equals to 3. A minus B will be 7 minus 3, that is 4. Okay, so your answer for this question is 4. Now question number 72. In this you have to find the percentage of carbon. So for the percentage of carbon, the formula is 12 upon 44 into m upon w into 100. M is what? Mass of CO2. W is what? Weight of organic compound. (12 upon 44 into 0.44 0.2 into 100. So it will be 60. Okay. Number of stereoisomers are possible in CO. Okay, so for this case you can generalize in general term. You can write this is your metal and this you can, these ligand you can write like this: A2, B2, C and D. This is your general case. Okay, for the stereochemistry, stereoisomer, we will generalize this, that this is this complex. Okay, A is your NH3, which is having 2 ligand, which are 2 ligand. B is your H2O and C is your Cl and D is your Br. So now we will draw and we will get to know. In the case of M, first case we can draw all the cis. Okay, A, B, B, C, D. So if you will see in this case plane of symmetry is present. How you will see the plane of symmetry? You can assume any one plane. Like if you are assuming this as a plane, so if you will see the both side you are getting B and B, it means POS is present in this case. Now we will see second case, that is M, B, C, D, A and E. In this case you will see that POS is present or not. So if you will draw this plane, you will see both the side AA is, you are getting similar atom AA. It means in this also POS is. If plane of symmetry is present, it means that molecule is not optically active. You will get only one molecule of that. Now in the third case you will see A, C, B, D and A. In this case plane of symmetry is present or not, we will see. We will draw one more plane. This is your plane. If you will see that POS is present in this also. Now the next case is M. You can see center of symmetry also and axis of symmetry also. Okay. So in this case we will see center of symmetry is not present, axis of symmetry is also not. Okay, how you will see axis of symmetry? Axis of symmetry you will see like this, that this is your axis, both side you are having same thing or not. You can see like this also axis of symmetry. Okay, so you will see in this neither POS is present, not axis of POS not present, COS not present and AOS is also not present. This is optically active. You will get two isomers of this. Now next one is M, A, D, B, C and B. Okay. Now in this case also, this is not, neither POS is present, nor COS is present, nor AOS is present. So this is also optically active. We will get two molecule of this, 1 1 1 2 2, and one more possibility is there, that is M B and B. These all are different molecule, okay. And how you will check that these are different? By the linkage you can check. In one I will tell you that in this BB linkage, DC linkage and AA linkage. If you will see in this, if you will if the linkage will repeat, then you can say that it is similar molecule. If you will see in this, this is BB linkage, but here no BB linkage, it means this is different molecule. Similarly you can see in all the rest of the cases, and you will find that all are different molecule. Okay, what about this molecule? This is optically active or not? So you will see that in this POS, COS, anything is or not. So you will see that this one is okay. If it is in this case, you will see that POS is not present. In this case, if you will see that POS is present, in this case POS is present or not, you will see. Just see POS is present or not. If you will draw like this, then also not present. In this, like this. Okay, what about this case? In this case, if you will draw, this one is optically active. Okay, in this case POS is not present, but plane of symmetry is present. In this case we have to see. Okay, so like this it is not present. Okay, in this case POS is like this, the plane is not present. Like this also it is not present. Okay, wait, in this POS is present. Okay, so if POS is present, it will give you only one molecule, and whereas this one is not optically active. In this POS is not present. So if POS is not present, it will have two molecules. So total you are having 8. I hope this one is clear to you all. Okay, now we will see the question number 74. In the question number 74, if H2O2 is an oxidizing agent, if it is oxidizing agent, so it will oxidize Fe. So oxidize, if it will oxidize Fe, it will convert this into Fe3 plus, and then the next one will be what? Fe3 plus, and it will reduce itself. So you have to write the balance equation. Okay, and in the second case it is MnO4 minus plus 5 H2O2 plus 6 H plus, and 2 Mn2 plus 5 O2 plus 8 H2O. Okay, so in this case you will balance this equation 5. So what is your x? X will be your 2. What is your y? It is again 2. What is x dash? It is 2. Y dash, it is 5, and z dash, it is 8. So if you will do the sum of this, 2 plus 2 plus 2 plus 5 plus 8, you will get total 19. Okay, now the last question is, consider that delta P is delta, if this is your splitting energy. Splitting energy is more than the pairing energy. It means pairing will take place, and this is the condition of a strong field ligand. Okay, and if the pairing energy will be more and delta will be less, it means pairing energy more amount of energy will require to pair, so it will get split. So this is the case of weak field ligand. Okay, so in this case what it is saying, that you have to tell about the magnetic moment. For the magnetic moment you should know the unpaired electron. So first you will find Ru oxidation state. Ru oxidation state is +2 because H2O is neutral ligand. Now you will write electronic configuration of Ru2 plus. Ru2 plus electronic configuration will be Kr 4d6. Now for the 4d6, H2O is weak neutral ligand, okay, weak field ligand or neutral ligand. But when your element is of 5d and 4d series, okay, then all the ligand except halogen will act as a strong field ligand. So H2O will act as a strong field ligand and it will do pairing of all the 6 electron. So number of unpaired electron will be 0. So mu is what? Under root n plus 2. So it will also be 0, okay, because n is 0. So keep in mind this thing, that when your element is from 4d and 5d and except halogen, all will act as a halogens except halogen, all will act as a strong field ligand. Okay, I hope this answer is clear to you. Thank you very much. In the question number 73, in this case, how the POS is present, that I want to show you. That if you will take these 4 elements, then you are having, this is your plane, then you will have 2 AA will be there. So like this POS is present. Okay, it is difficult to see POS in this case, but you can see. Okay, so in this case the POS you can see like this. Thank you very much.